What happens when a city realizes that its entire metro system has become outdated? Suburban Rail Loop, a massive 90 billion Australian dollar metro megaproject, is being built to solve exactly that problem. For decades, Melbourne, like many major cities around the world, designed its transport network to move millions of people from the suburbs into the city center as quickly as possible. But today, residential districts, universities, and technology hubs are spreading across the outer suburbs, turning the old metro model into a massive bottleneck. And beneath the streets of Melbourne, 4 tunnel boring machines, more than 100 meters long, are operating 24 hours a day to create the largest underground rail network in the city's history. With a population of more than 5 million people, Melbourne has officially become the most populated city in Australia. However, only around 3% of workers there use the metro system to commute. The problem comes from a transport model built in the mid-20th century, where almost every metro line is designed to funnel passengers into the Central Business District, CBD, before branching out again. This has turned central Melbourne into a massive bottleneck, limiting the capacity of the entire network and making travel between suburban areas extremely inconvenient. To understand the problem more clearly, a trip from Burwood to Caulfield, 2 areas located less than 15 kilometers apart, takes only around 16 minutes by car. But by train, passengers must first travel into the CBD and then back out again, increasing the total travel time to more than 1 hour and 20 minutes. To solve this issue, Melbourne is now building the Suburban Rail Loop, a massive orbital metro line designed to directly connect suburban areas without passing through the city center. Announced as one of the most ambitious infrastructure projects in Australian history, the Suburban Rail Loop, or SRL, is a plan to build a roughly 90-kilometer orbital metro line surrounding Melbourne. Instead of forcing every train to pass through the Central Business District, CBD, like the old network, SRL will create an entirely new transport system where suburban areas can connect directly to one another through underground rail. Melbourne is betting heavily on this project because the city's population is expected to reach around 9 million people by 2050. And without major upgrades starting now, the transport network could eventually become completely overwhelmed by congestion. The entire project is divided into 4 major stages, with total investment costs estimated at more than $90 billion. If long-term operational costs through 2084 are included, the total figure could rise to nearly $216 billion. The first stage, SRL East, stretches 26 kilometers and includes 6 completely new stations, making it the first section to begin construction, with completion expected by 2035. These stations are not designed as simple train stops. They are planned as large-scale transport superhubs integrated with existing rail lines. Around the 6 stations alone, the project is expected to create approximately 70,000 new homes, helping address Melbourne's growing housing shortage. The second phase, SRL Airport, will extend westward and connect directly to Melbourne Airport, which is currently one of the 6 busiest airports in the world without a direct rail connection to the city center. This section is expected to be completed between 2043 and 2053. The final 2 stages, SRL North and SRL West, will continue extending the orbital route toward the north and northwest, eventually completing the entire loop around Melbourne. Before Melbourne could begin constructing the Suburban Rail Loop, the city first had to solve the bottleneck at the heart of its transport network, the central area where nearly every rail line converged and became heavily congested. Beneath Melbourne lies a complex maze of underground infrastructure built up over decades, including sewer systems, water pipes, electrical lines, telecommunications cables, and many other utility networks. Because of this, the first major task of the Metro Tunnel project was not tunnel excavation, but relocating these underground systems away from the future rail corridor. One of the most complicated operations involved relocating the South Yarra main sewer near the Domain precinct. Instead of tearing open entire roads across the city, engineers used underground tunneling methods to construct a new sewer line beneath Melbourne, minimizing disruption to traffic and daily life above ground. Once the key utilities had been relocated, construction crews moved into the next phase, building deep foundations and retaining walls. Massive drilling rigs continuously bored deep into the ground to create the structural foundations for underground stations, and large excavation shafts where tunnel boring machines would later be lowered beneath the city. This became one of the most difficult phases of the Metro Tunnel project because all construction had to take place beneath a fully functioning city. Traffic continued moving, businesses remained open, and daily life carried on as normal. While directly beneath the streets, enormous underground structures were slowly being built in preparation for the largest tunneling operation in Melbourne's history. After years of site preparation, underground utility relocation, and construction of massive excavation shafts, the Metro Tunnel project finally entered the phase of lowering giant tunnel boring machines, or TBMs, deep beneath the city. Melbourne used 4 enormous TBMs to excavate 2 parallel tunnels underneath the urban area. Each machine was more than 100 meters long, weighed over 1,100 tons, and operated almost like a fully mobile underground factory. At the front was a gigantic rotating cutter head constantly crushing soil and rock, while behind it stretched an entire system of conveyor belts, hydraulics, power supply, ventilation, and tunnel lining installation equipment operating 24 hours a day. The TBMs were lowered underground through giant shafts prepared in advance. Once the cutter head began rotating, the machines excavated layer after layer of soil ahead, while conveyor systems transported the excavated material back to the surface. At the same time, precast concrete tunnel segments were installed directly behind the cutter head by robotic systems, forming the protective lining of the tunnel as the machine advanced. Inside each TBM was a control room equipped with screens displaying the machine's position down to the millimeter compared to the designed tunnel alignment. Lasers and sensors constantly monitored tilt, rotation, and direction to ensure the TBM stayed perfectly on course while passing through different geological layers. Even a deviation of just 5 centimeters could prevent future installation of railway tracks and electrical systems. Because of this, survey teams repeatedly checked alignment after every meter of progress, while operators adjusted the drilling angle using sophisticated hydraulic jacking systems. Each TBM operated around the clock with a crew of roughly 10 people working across 3 shifts. Inside the machine was a small cabin equipped with a kitchen, coffee machine, and even a restroom, since some shifts lasted for many hours deep underground. Fresh air was continuously pumped through ventilation systems, and every engineer carried communication equipment to maintain constant contact with teams on the surface. The 4 Metro Tunnel TBMs were named after notable local female figures: Joan, after Joan Kerner, the first female Premier of Victoria; Meg, after Australian women's cricket captain Meg Lanning; and Alice and Millie, named after 2 World War II volunteers. The first pair of TBMs, Joan and Meg, were launched from Arden Station in 2020 and began tunneling southeast. The second pair, Alice and Millie, started from the opposite direction several months later, tunneling northwest. All 4 machines simultaneously pushed deeper beneath Melbourne, advancing roughly 15 to 20 meters per day. Then in mid-2021, a historic milestone was reached. Joan and Meg finally met Alice and Millie at a designated underground breakthrough point, successfully completing excavation of the twin tunnel system. After the TBMs completed tunneling, the tunnels began receiving their railway tracks and electrical systems. Instead of using traditional ballast tracks, the Metro Tunnel uses slab track, a ballastless rail system built with precast concrete slabs that helps reduce noise and maintenance costs. In shallow tunnel sections near residential areas, engineers use floating slab track, concrete slabs placed on springs or rubber pads that absorb vibrations like giant shock absorbers. Alongside the rail installation, the electrical system was also developed, including Victoria's first underground power substation, located beneath South Yarra Park. This facility uses nearly 37 kilometers of different types of cables to supply enough electricity for train operations, lighting, and emergency ventilation systems. In addition, the new high-capacity signaling, or HCS system, based on Alstom's CBTC technology, allows trains to run closer together at much higher frequency. This helped Melbourne achieve a true turn-up-and-go system for the first time, where passengers can arrive at the station whenever they want without needing to plan around train schedules. Although the Suburban Rail Loop has been praised as a major transformation for Melbourne's transport system, huge questions still hang over the project. The first issue is financing. With a total cost exceeding 125 billion Australian dollars, SRL is the most expensive infrastructure project in Australian history. But the biggest concern is that around one-third of that money, roughly $40 billion, is expected to come from value capture, meaning taxes and revenue generated from rising property values around the new stations. This model has never been tested on such a large scale in Australia, and many experts believe the assumptions are overly optimistic. At a time when inflation is reducing purchasing power and pressure on public budgets continues to grow, securing enough funding for a project that could last 60 years is a massive gamble. The second challenge is political controversy. Critics argue that SRL is not just a transport project, but also a tool to reshape the political map in Melbourne's rapidly growing outer suburbs. By building stations in areas traditionally considered opposition strongholds, the Victorian government could attract new voters and create long-term political influence. The question is whether that outcome is really worth spending tens of billions of dollars from taxpayers' money. And finally, the biggest question remains: can a project scheduled to continue until 2084, across multiple premieres, economic crises, and changing political priorities, actually be completed? The history of mega transport projects around the world shows that the longer a project takes, the greater the risk of delays, budget cuts, downsizing, or even cancellation when governments change. Melbourne is betting that its project will be different. But to succeed, SRL will require not only enormous amounts of money, but also decades of uninterrupted political commitment, something extremely rare anywhere in the world. So why is Melbourne willing to take such a massive gamble? Because if successful, the Suburban Rail Loop could fundamentally change how the city operates. SRL would relieve the major bottleneck in the city center, allowing the entire metro network to increase its capacity significantly. Existing rail lines would no longer be forced through the crowded CBD core, and train frequency across the network could improve dramatically, from one train every 20 minutes to every 5 to 10 minutes, making public transport a truly competitive alternative to cars. More importantly, SRL directly connects suburban areas to each other. A trip from Burwood to Caulfield, which currently takes around 1 hour and 20 minutes by public transport, could be reduced to just 16 minutes, similar to driving time. Once people are no longer forced to travel into the CBD and back out again, train usage is expected to rise sharply, reducing dependence on private cars, a major benefit for both the environment and traffic congestion. In addition, the new SRL stations are not designed as simple train stops. They are planned as urban hubs that combine housing, offices, shopping centers, and public spaces. Around each station, entirely new residential districts are expected to grow, followed by schools, hospitals, and supporting services. This means SRL will not only change how people travel, but also reshape Melbourne's urban development for decades to come, moving the city toward a transit-oriented development model already used by many leading global cities. And finally, despite all the controversy, it is impossible to deny that SRL is one of the largest metro megaprojects in Australian history. If successful, it could become a model for cities around the world that are struggling with outdated transport systems built around mid-20th century thinking. Melbourne may be betting on the year 2084, but the benefits could begin arriving much sooner, as soon as the first stations open. For decades, Melbourne developed around a transport system that forced nearly every journey to pass through the city center before spreading back out to the suburbs. And the Suburban Rail Loop is Melbourne's biggest attempt to break away from that old structure. This project is not simply about building another metro line. It is an attempt to reshape how people move, live, and develop cities throughout the 21st century. If successful, The SRL could become a model for future megacities around the world. But if it fails, it may become one of the most expensive warnings about the limits of giant urban megaprojects.